Good morning, my math studies students. Today we're taking a look at writing the equation of tangent lines. Let's go back all the way to the beginning of this chapter when we were talking about estimating the slope of a curve using a related tangent line. So in the beginning of this chapter, what we did was we said if we had a curve and we wanted to find the slope of this curve at this point, what we would do is we would come in and we would draw a tangent line that we thought would best represent that, or the tangent, and we would find the slope of this line, and that would be the slope of this curve at that point. But we said, oh, well, that's not very accurate because, our tangents are all going to be different depending on how we view it, right? Well, then we learned that the derivative can be used to find the slope of the tangent and the slope of the curve at that point using algebra and the derivative. Well, now we're going to go back to writing the equation of the tangent line, but instead of eyeballing it, we're actually going to use the derivative to do so. Let's take a look at this example that I've got here. I've got a curve f of x equals x cubed. I want to write the equation of this line tangent to this curve at -1, -1. So I want the equation of this red line right there, right? Well, because it's already drawn out, it's pretty easy to write the equation of the line. Let's not forget that the equation of a line, the easiest form is what we call point slope form, which is y minus y1 equals m parentheses x minus x1, where the x1 and the y1 was the point that's on my line, and the m is my slope or my gradient. Well, we know that my point of tangency, the point where the red line meets the curve, is -1, -1. And we know that the slope of this red line, we can just count it, to go from this point on the line to say this point on the line, aren't they going to rise 1, 2, 3 and run 1? So my slope would be 3. So the equation of this tangent line would be y minus 1, so y plus 1 equals m, which is 3, parentheses, x minus 1, which would be x plus 1, which would be the equation of my tangent line. Now, we did this using our eyes. Could we have done this using calculus? Well, the only difference between this problem using our eyes and this problem using calculus is that we could have found the slope instead of using the line that was already drawn for us and counting the slope. We could use the derivative. So let's take a look at that now. So let's assume that we didn't know our slope and we wanted to find it using the derivative of this function f of x equals x cubed. Well, if I take the derivative of f of x equals x cubed, I would have gotten f prime of x equals 3x squared. Now there's my slope equation. So to find the actual slope at this point, -1, -1, I'm going to plug in this -1 for x into the equation like we've been doing, and I'll find that my slope is equal to f prime at -1, which would be 3 times -1 squared, which would be 3. And notice I'm getting the same slope that I was getting before. I'm still using that same point that we were given, and I'm going to get the same equation of my tangent line. Now, the next thing is, this equation was in point slope form. It's the easiest because there's not much math once you know your point and your slope. So what if I wanted to rearrange this into a different form? Well, if I wanted to do that, couldn't I, say slope-intercept form, couldn't I first distribute the 3, then subtract the 1 across, and this would be the same tangent line, just in a different form, called slope y-intercept form, slope-intercept form. And then lastly, if I wanted, say, standard form, I could subtract the 3x to the left side and get -3x plus y equals 2. And now this is my equation in standard form, but it's still the same tangent line, okay? So depending on what the question asked for, what form it wants, I could write it in point slope, slope intercept, or standard. All right, let's do one more example. All right, let's look at this example. It says, write the equation of the line tangent to f of x equals 3x squared plus 6x minus 5 at x equals negative 3. So in this problem, I don't have my graph drawn out. I don't have my tangent line drawn out. So I'm kind of just imagining what this might look like. I know that this would be a parabola, and his vertex might look something like this. So that parabola, that's not what I want. That parabola would look something like this maybe, okay? And so at x equals negative 3, something like right here, I want the equation of that tangent line, right? Well, to do this problem without actually having to graph it, the first thing I know if I'm writing the equation of my tangent line, I know I need a point that's on my line, and I need my slope. Now, in this case, my point, I'm not given the full point. I'm only given half of the point. I'm given the x-coordinate to be negative 3. I still have to find the y-coordinate. Well, remember that this original equation, his whole purpose is to find y values given an x value. So I can find the y value by plugging negative 3 in for my x. And when I do this, I get my y value to equal, that would be negative 27 minus 18 minus 5, which I believe is 4. So I know that when x is negative 3, y is 4, so my point that's going to be on my tangent line and on the curve at the same time is negative 3, 4. Now I've got to find my slope. To find my slope, I'm going to have to use the derivative. So I'm going to rewrite the equation here so I don't have to look back. 3x squared plus 6x minus 5. So the derivative of this guy would equal 6x plus 6. Now, if I plug in negative 3, the x value I was given, into my slope equation, I'd find that my slope is equal to the derivative at negative 3. And when you do that, you get negative 12. So my slope is negative 12. So the equation of my tangent line would simply be y minus 4 equals negative 12 times x plus 3. And there's my tangent. Let's do a bonus problem. Same idea, but this time, ladies and gentlemen, my function looks quite different, right? So how do I do this problem? Well, again, anytime it says write the equation of a tangent line, I know I need a point that's on my line and my curve at the same time, and I know I need a slope. So my job is to find the x, the y, and the slope. Well, again, I'm given the x to be negative 1. So to find the y value, I plug negative 1 into the original, because that's his purpose. And when I do this, I'm going to get negative 1 minus 2 plus 1 over 1, which I believe, kids, is just negative 2. And so I know that when x is negative 1, y is negative 2. So the point that's on my tangent line is negative 1, negative 2. Now it's time to find my slope. Well, again, going all the way back to section 20D, this equation right here is not in derivative-friendly form because of that variable on the bottom. So what I need to do is to first split him up into 3 different fractions. I can divide the first term on the top by x squared. I can divide the second term on the top by x squared. And I can divide the last term on the top by x squared. Now when I simplify this, x cubed divided by x squared is x. 2x divided by x squared is 2x to the negative 1. And then lastly, I'm going to get x to the negative 2. Now I'm ready to take the derivative, which would be f prime of x equals, the derivative of x is just 1, then minus 2x to the negative 2, minus 2x to the negative 3. Rewriting this, getting rid of the negative exponents, I get 1 minus 2 over x squared minus 2 over x cubed. And there's my derivative. Now, I want to find the slope using this equation and the x value of negative 1. So plugging in negative 1 in, I'm going to get f prime of at negative 1 equals 1 minus 2 over negative 1 squared minus 2 times negative 1 cubed, which would equal 1 minus 2 over negative 1 squared. Well, negative 1 squared is 1, so this would be minus 2. And then minus 2 over negative 1 cubed is negative 2. Well, that's become a positive, so I get just a slope of 1. So going all the way back up, I know that when my value of x is negative 1, my slope must be 1. So my equation of my tangent line, putting all this information right here into use, it'd be y plus 2 equals 1 parentheses x plus 1. Now, if you recall, we really don't need, if it's a 1, we don't need to put it there. So you can just put that as your answer as well. In fact, that's the preferred answer. Alrighty, guys, that's the lesson. Talk to you later.